So good afternoon to one and all. I welcome you for the case study video of fluid mechanics. So in this we already studied in the fluid mechanics about various types of pumps. We know that the pump is used to increase the kinetic energy of the fluid. That is, it converts the potential energy of fluid into kinetic energy in the form of pressure energy. Once the fluid is pressurized, we can create the pressure difference and it can be transported to the various locations. So here we have a case study of gear oil pump. It is why it is called a gear oil pump. It has gears. Okay. So the gear pumps are called a positive displacement pump because it gives constant amount of fluid for every cycle. Okay. So here we have the setup, experimental setup. This is called the pump and it is connected with the motor. So this setup is called a motor and it is directly coupled with the pump. So this is called the gear pump, and at the bottom we have a reservoir. So reservoir is nothing but it is the tank which is used to hold the oil. And this is called the overhead tank, where the pump is pumping the fluid from the reservoir to the overhead tank. And we are going to measure the suction head and delivery head for the pump, and how much energy is consuming in the energy meter. Okay, for filling a particular height, how much energy is consuming and how much pressure head and suction head is there for the pump. So this is what about the experimental setup. So coming to the gear pump, there are two classifications. One is external gear pump and internal gear pump. Here we are using two gears that are externally meshed. Then it is called the external gear pump. Where the two gears are internally meshed, then it is called as internal gear pump. So here we have an external gear pump where the two gears are externally meshed, and if you rotate one gear, then another gear will rotate. So both the gears are rotating. The unmeshing action of the gear increases the volume. When you suddenly increase the volume, it will create a partial vacuum inside the suction side. For example, the rotation aeromat is there on this side, counterclockwise side. When you rotate this gear, because it is connected with the motor in a counterclockwise direction, another gear will rotate in a clockwise direction. Both will cause unmeshing. Unmeshing increases the volume and it will take the fluid from the reservoir. Then it is carried by means of teeth, and finally we have meshing on the opposite side. Then the meshing increases reduction in the volume, so the fluid is pressurized, and the pressurized fluid is sent into the overhead tank. So while taking how much amount of suction is created, that will be monitored in the meter. Here we have a suction head meter. So we can monitor the suction head, how much suction is created. And once it is delivered, and we have a delivery head meter, is this tube connected with the delivery meter. So the delivery pressure can be monitored by means of this. Then, for example, we are considered about 10 centimeter filling height. Okay, so how much time it is taken, we have to measure the time. Then finally, how much energy is consumed. Here we have an energy meter for filling a 10 centimeter height, how much units it is consuming. Then we can make calculations. Okay, so this pipe is mostly used in power hydraulic applications. That is used to actuate the single acting and double acting cylinders. Okay, while doing an experiment, we have to measure the height and filling time, then discharge height, delivery height, and the energy consumed. So we can do calculations. Finally, we can draw the performance characteristics curve for the pump. Okay. If you have any doubts, you can ask.
How will you increase the discharge of the pump?
The discharge of the pump can be increased by either increasing the speed. So if you increase the speed, then you can increase the discharge, or to increasing the volume. Okay. So here it is not possible to increase the volume because this is the closed experimental setup and it is not varying. We can increase the speed of the motor and thereby increasing the discharge of the pump.
So what is the difference between positive and non-positive?
Positive displacement pump, for every rotation it will give constant amount of fluid. For example, 10 ml of fluid is discharged. One rotation, 10 ml of fluid is discharged. Then it is a constant value. Then it is called a positive displacement pump. For a single rotation, the fluid discharge is not constant. For example, one rotation it delivers 8 ml, another rotation it delivers 12 ml, another rotation it delivers 10 ml. It is not constant. So that pumps are called a non-positive displacement pumps. So I hope this lecture is useful for you. So thank you for attending this lecture. Thank you.
Thank you.